So in this video, we're going to continue our examples of how to deal with radical switching. And in this case, we're looking at simplifying the expression cube root of the fourth root of the square root of 125. Wow. All right. Hopefully you don't encounter any of these in the wild, but maybe you will at some point. But I'm going to do this to illustrate the point that this can actually break down a little bit more simply if we just make use of our radical switching rules, or moreover, just exponent rules and how we manipulate exponents. So how does this work out? It's going to be, well, let's rewrite the first original expression. We have cube root of fourth root of square root of 125. So now if we try to break down 125 using a factor tree, what do we get? We have 125, that breaks down into 5 times 25, and 25 breaks down into 5 times 5. So I have a cluster of 3 5s here. However, the first thing I'm looking at inside all of these nested square root, or in these nested radicals, is a square root of 125. Sure, we could cancel out 2 of them, but that's not going to be good enough, especially when I see that I have a cube root all the way out here, and I know I can swap the order of these radicals. So if I want to rewrite this, I can write this as, well, I can swap the order of any of these because it's just radical of radical of radical. So I want the cube root on the inside, and I want to swap that out for the square root. So this gives me square root of fourth root. I'm not moving the fourth root, I'm just moving the cube root and the square root. And then I have the cube root of 125. Rewriting it, knowing that I have this nice factorization here, I have the square root of the fourth root of the cube root of 5 cubed. Okay? So the cube root and the cube cancel out, leaving us with just a 5 on the inside of this fourth root here. So I have the square root of the fourth root of 5. Can I do any better in this case? Not really, because 5 is completely factored. Even if I swap the square root and the fourth root, I'm not going to be able to do anything with this 5. It's already broken down as far as it goes. So what can I do to make this simpler or more eye-pleasing? Because this is still very ugly. What I'm going to do is I'm going to convert this to its exponential form so that at least we can plug it into a calculator. So at this point, I'm going to rewrite this as the square root of 5 to the 1/4 power, because the fourth root is equal to a 1/4 power on this 5 here. Similarly, I'm going to rewrite this square root as a 1/2 power. So I get 5 to the 1/4 to the 1/2. Okay? Now, at this point, I have 5 to the 1/4 to the 1/2 power. So if I have a power of a power, you can multiply the powers. And you do that just as you normally would with your fraction multiplication. So this gives us 5 to the 1/4 times 1/2, all in the exponent. Okay? This is equal to 5 to the 1/8 power. Okay? And at this point, we can't really do much more than this because we've already broken down this 5 as much as it gets. So all we did was just convert all the radicals to a power, so we have 5 to the 1/8. And if you really wanted to figure out what 5 to the 1/8 is, you can plug that into your calculator. Okay, so at this point, this is as simplified as it's going to get and as eye-pleasing as it's going to be. Also, as I've probably said in other videos, simplification is basically in the eye of the beholder, or in the eye of my math lab, or whatever you're submitting homework problems to. Simplification is like, okay, how pretty do I need it to be in order to solve another particular type of problem? So it's all in the eye of the beholder. It's very subjective when someone's asking you to simplify. It's basically another way of saying make it prettier. Okay? So it's subjective, but it sometimes helps with solving bigger problems. Okay, so that's the end of my rant, and that's the end of this example. We're in good shape, and I'll see you in the next difficulty.